What's going on, everybody? We're back. Wednesday, finishing up the RBD, controlled RBD effects. So it's like attracting, reforming, reassembling geometry or any kind of shapes using packed RBDs. What's up? Long Walk to Than, how's it going? Steve GH. Yo, 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 yo. So we'll just open up the scene, just continuing kind of what we started over the weekend. So this is 7/7/12, or if you go to the Discord server, there's a link to it below this stream on Twitch in the About tab. There's a link to the Discord. You could get the scene file. So we'll just go ahead and get started. It's probably going to be a bit brief today, just a bit busy with other stuff, so we'll just kind of jump right into stuff. So one thing I did notice was I believe that this model came with, or somehow it had a CD color attribute already baked into it. And that's the reason that I was having trouble last time trying to get the colors to show up. So I think it's kind of a bug, or it was both a bug and just being sloppy on my end. So even though there's no color once it's packed, before we're converting it into packed RBD or packed fragments, it has a point color attribute. And then it turned out that that was what causes this conflict, to not show random colors. So if you just go up to the top, you just do rename, you remove the existing point color. So it'll take a second to redo the remesh and fracture and stuff like that. So now you can see that we have our visualization of that. Or if I scrub through, we can now see our state changes, or the color changes. Dubtronics. So we're just finishing up, doing like one more day of refinement or polish on this controlled kind of RBD setup. So I could just walk through everything to get people up to speed if they're just coming in. So we're just using this model. I just use this stash node to embed it into the scene file, like the HIP file, and then using this to clean up that color diffuse attribute, or the CD point attribute somehow got added to things. This was just different approaches to remeshing or down-resing the geometry. So this speeds up the fracturing process if there's less faces or less polygons to fracture. The Voronoi split will run a lot quicker, and the RBD sim can just simulate using lower resolution pieces. There's ways we could fracture and then like rebind or reapply the simulation to those high resolution pieces, but just for testing and setting this like RBD forces up, I'm not too concerned about that area of things right now. So we're doing this pretty typical Voronoi fracture. This one is just setting the normals before we cut it, and then this one you have to be careful just looking at this group. It's only applying or recalculating normals for the inside faces, for the newly cut polygons. So if you explode it, then you can see kind of what's happening. And then I'm just storing the rest on the point position and packing it, creating the name attribute. So now we have packed RBDs ready to go. And then this is like the rest kind of centroid, or it's a bit different. We're storing rest both before it's packed and after it's packed. Rendering fractured pieces as transparency so that you don't see the fractures before it happens. Well, Mr. Dubtronics, have I got the content for you? Let me see if I think I have it. There's a node. I think that there is a node. There might be a newer node. One thing you can do, this is like older, where did it go? This is an older blog post that I had written on my old website. You can use this visibility property and use that to like hide faces or turn on faces. So that's kind of what I was showing here with it, using this visibility property so that you don't see like those edges of fractured geometry. I didn't know that there was a new node for it. I haven't used it ever. But my technique to usually solve that issue is to scatter points. Oh, okay, it's a new node in the RBD bullet. Just in this SOP solver, or the simple solver. Connected faces. So usually my approach, like if you do there's different ways to do this, but I was usually doing this DOP import, using this node to get the transformation points of the packed RBD. So if you just do create points to represent objects, then you should get, might need to switch this around. I guess it starts with RBD. Black Ruku, thank you for the Twitch Prime. So we'll just switch this to points. Leave it there. Black Ruku, how's it going? Thank you for subscribing. I appreciate it. Let's go. So what this does is it brings in points that have this orient P pivot. It just is like the attributes that the copy SOP is expecting. So you can use it with transform pieces. Where did this one go? So this way, we want the points to go into here, and then if you just do like the pieces before the simulation, this will basically apply the simulation transforms just using this node. So what I was usually doing is like if I do this blast node, you do the same expression that we were using to only calculate normals for the inside surfaces. You can use that same expression with this blast node. We just want to unpack it before we do that. So this way, we're only keeping interior faces. And then what I was doing was usually scattering points here. You might want a lot of them. And then because this, so I just don't want this stuff here to be time dependent. So I'm just gonna put down a frame hold. And then these scatter points, I believe we need them to get the piece attribute, or I think we need the name attribute. So I just need that promoted to point level from primitive so that the points should inherit it. So I think we need name, and then we're good to go. So now this point cloud is transforming in the same method that the simulation happens. So if we look at our simulation results, we template these points on. Where did they? They're only on the inside faces, so they're a bit harder to see. Maybe this way. I don't know why they shouldn't have to be that big, and maybe because they're like halfway inside of it. But this way you have points that are mimicking the simulation's kind of performance or results. And what I was doing was basically taking these points and saying, like, find the nearest edge that hasn't been fractured, or like the nearest edge or face that this point doesn't belong to. And then just keeping track of that distance over time. And then once it separates over a threshold, I would mark that face as like visible or fractured. So that's my technique to do it. It requires a few more steps and maybe a bit of vex. I believe I usually would do it in a SOP solver so that like once the face becomes visible, it doesn't flip back to being invisible. So I might have, I'll see if I could find a file or something like that. I think I made an example file for it a while ago. I think I have one somewhere in my Google Drive. So I'll try to find that, and if I do, I'll put it in the Discord or something. But that's a good generic approach because it will work even if you're not doing like an RBD simulation. It's a very generic thing that, like, if you're just doing a procedural fracture that doesn't even have a simulation, you can still use it to reveal edges and stuff like that as soon as faces separate. So the vex is a little bit technical. I'm not going to get into it right now, but that's the kind of basic approach to doing things. So that may help. Was having issues on the new node, so it would be cool to look at and test. Yeah, I think I remember seeing that was a feature, and I think it's pretty handy, but I never. The Chatterino crashed. I never tried it myself, but it should be pretty nice to use. So we fixed this random color. Now we can visualize everything pretty easily. And just continuing on with our setup, what we were doing is basically through these colors doing kind of different state changes. So I don't know if these forces here should be masked. I don't know why it started. You guys remember what I was doing with those? Like they shouldn't be releasing until the color changes. But one of the things I wanted to go over today was maybe just switching these expressions out so that they are like instead of colors like this, we'd switch the vex expression to be integer attributes, kind of like groups or something like that. So you might have released section, and then you might have like reform group, or just an integer attribute that's like 0 or 1 for true or false. Just to make it a bit easier, like doing this 1- nonsense with different components of the color channel is a bit sloppy, especially if you give this to someone else to start using for like a production shot, or they go into an older scene. It just becomes a bit, it's like unlabeled, or they have to do a few more steps to decipher what this stuff means. So that's a better idea, to just be as clear as possible whenever you can. And then the other thing was like at the end of this simulation, the way things come back together. We're doing this in the simulation to get it as close as possible. And then we had a final node here that's just blending to the final position to seal the gaps and line everything up again. But there's like some missing things. So I was going to implement like a timer or a counter. So basically, once that reassemble state or reassemble color is switched on, after a set amount of time, just override and like force everything to come together. I think that that's just a bit more predictable and reliable, instead of like, we were running into some issues over the weekend with things you would see up there, or some things just didn't get close enough and then they would never get into their final position. And then the way that all this stuff happens, it's just a bit fake, or it's a bit weird. So we'll just try to look at that at the very end. So this is what we were doing to set our different colors. Basically, I was kind of hastily setting this up over the last few streams, just to, it's kind of like you don't really know the direction you're going to take when you're setting everything up, so you're kind of just working quickly to try to see if the approach is viable or not. And then once you realize this is the direction or this is the way to go, you generally just want to go back and like clean things up, label things a little bit more clearly, and get rid of stuff you weren't using or excess stuff. So that's kind of what we'll do here. This was a previous method I was thinking about using for releasing or selecting things by the bounding box position. We'll just get rid of that. We're using this noise to like grab different areas and erode or expand things. Yeah. So let's just look at this VOP and look at our intentions. So I was going in here with this red channel and using this compare with this animated slider to set this to either on or off. But that's a bit confusing, using the color and then having it like white to black. So instead, I think we want to compare the other way and do less than. So now this, I'm just switching this to visualize the red channel because that's what it's hooked up to right now. Starts at 0, and then after enough time just turns to 1. So it's just kind of like false or true, where it's like a light switch. You just have it off, on. We were doing that by the length of the point position. We might want to... I guess we'll keep it. I guess we'll keep it as the point position. I might want, I'm just going to offset the point position real quick. Because right now it's starting at the centroid, I believe, so it doesn't appear like a transition because you can't really see the center where the stuff is like coming from. So if I just add a vector to the position that's kind of like doing a translation, I should start to see like these things not click on all at once. I thought I solved my issue of having the color. I think I know what. I think I know what's happening. So it's this packed color is still a bit buggy. I think for it to properly show, we just need to make sure that it's on the primitives. So I'm using this just to offset or change the centroid of the kind of growth, like activation region. So if we move this up, it's kind of like the opposite. You're kind of like subtracting like adding a negative number is the same as subtracting. So we're shifting it up by 0.4 units so that it starts at the forehead. And then want this to be less than? Yeah. So it's like a light switch, which starts off or 0, and then we're setting this end value to 1. So instead of that, if you just do maybe bind this, you just can set attributes. It's like if you're using Vex or the Wrangle, using the @ symbol to like define or create a new attribute or write to an existing one. I'm just going to call this release, maybe released to past tense, and we'll just set it to an integer. I think I grabbed the bind import, but if you just set this to like when input is connected, then you can also use it to write out values. Umair, how's it going? It's been a couple days. It's been good. It's been a busy week for me so far at the start of the week, just with the regular work stuff. So we've written to this attribute, and basically it's getting the same value as this color that we're visualizing. So instead of this, if I just go to my spreadsheet, we see released, and we see it changing from 0 to 1. So this is just going to be a little bit easier for us to reference later on. Instead of remembering like which channel of the color we were storing like the state and what reason we were setting those values, this is just more transparent into what our intentions were and stuff. And then we'll just do the same idea with this one. So we were doing the blue channel, and using this noise function, we were setting things to be, we'll just call this one like reform, I don't know, reassemble. So we have our two states, released, and let's just do rebuild. And then this one, I think we want to flip our comparison around as well. So again, like a light switch, when this is 0 or off, it won't be rebuilt. And then when it switches to 1, that will mean we want to rebuild it. So I could get rid of that color stuff now, and just clean this stuff up a little bit. And then this one will just be set, rebuild, and released state attributes. It's a little long-winded, but I don't know. You could also do it in the comments section or whatever if you don't want your stuff being that cluttered. But I usually don't mind these names getting a little bit long. And then this way, like if you want to, you could promote one of these to a primitive attribute, and then just using color, go in here and do ramp from attribute. We'll do primitive and do released, or rebuild. And then we could visualize it again with color if we wanted to this way. It's a little bit more steps, but I think it's better to be more verbose or like clearly named in your main chain, and then visualizers you can be a bit messy with because it's kind of just temporary stuff. If you were passing this geometry along to someone else, like those attributes of released or rebuild might be more useful than just random colors changing. They wouldn't know what those meant. So now we just need to go in here and update things. So this one is constantly retrieving information from the source geometry or the input geometry, and we were pulling in the color value every frame to retrieve that animation or the changes of the states. So instead of doing it like this, this is going to be an integer, and we have released, and then we just want to keep copying it or overwriting this simulation attribute with the updated source one, because this geometry, when you pull it into the simulation, it only gets updated once. You can use this overwrite attributes to keep retrieving updates. You can do it manually with this one. I was doing some more math in here, so I preferred to have some extra area to type like other code or expressions. This one you can only just simply copy or retrieve new information. So we have released. So basically, if you don't update these, they'll just keep getting the same value from the previous frame, which will always be out of date. Like, it will never get new information from upstream unless you like manually overwrite it like this, or using this overwrite attributes toggle. So we have our final state, rebuild. All right, so if we just wanted to double check, if I just go into my spreadsheet here, you go all the way, bullet adds a lot of attributes. PHIJKLMNOP, there it is. So they're always alphabetically sorted from left to right. And then it added a few more, so I lost it. All right. So we're getting updates. So I'm just verifying that I've wired that stuff up and it's behaving properly. You could, again, if we wanted to verify it this way, just plug this stuff in. We could see rebuild change here, or visualize it this way and see it change there. It just depends how visual you want to work or how technical. You want to be deep in the sheets, deep in the spreadsheets. Some people don't really like to look at that geometry spreadsheet. So this is working. We're in good shape with that. And we should be ready to go. So let's replace these now. The intention with this is to mask out the pop force whenever these conditions weren't met before. So we could still do 1- if we want to do like opposite, but basically we multiply it by this released. You can just comment that out, and maybe I'll just bypass all this stuff for right now. So it looks like it's working. We could paste that and paste that. So I think what's happening, why the rest of this stuff is moving, is because this is still considered active geometry. So these pieces are getting a force value, and then they're pushing other ones out of the way. So that's why some things might be moving before other things are. Because basically all this pieces are live, so they're allowed to move around, and once these start pushing even the ones that aren't considered released yet, they aren't completely static. So they're still allowed to move or get pushed around. So if we want to fix that, we were doing it using this active, I at active. This is kind of like stopped for particles. It's basically like a static object if any active value is set to 0. So we want this to just be equal to released. So when our light switches off for the released state or we're unreleased, just be inactive. So hopefully it's a bit, I don't know, hopefully my naming scheme makes sense. I think it's at least better than doing like cd.x with like 1 minus. That just is, you open the scene up the next day and you like get a headache immediately or something. So now because we're setting that active based off of the released state, looks like some are never getting released. Or maybe it was, I don't know, we'd already turned off and sleeping. Is this number might not just be getting high enough? Because I think when I shifted the centroid of that effect, it changed my distance, so that area was out of the range at that point. All right, so we've got our released somewhat working. We've got things basically being set to inactive, or the active state is turned off when the released state is turned off, or before it's turned on, essentially. So let's start getting our, we could put in maybe at the top, I'm just going to put in kind of global things. Like these are things that aren't defined or don't depend on states. So like this, we were doing after the rebuilt state was turned on. We were disabling collisions after the rebuilt state was turned on to get stuff reforming so that it could move through each other if it needed to. And the drag was part of the rebuilding process, and the attract was part of the rebuilding process. Then this drag spin, this is kind of like, I'm considering it a global setting. We were kind of using it like rotational stiffness. To turn it on or off if needed. But I'm just trying to compartmentalize things so that it becomes a little bit more clear. So basically let me just make sure all this stuff, sometimes these wires trick you. So all this stuff here is part of the rebuilt states. And then with this second multiplication or mask application, we basically want to use the rebuild state, but this one we do want to do a 1 minus. So this is just saying the inverse, or when rebuild is turned on, turn this amplitude off. So if either of these evaluate to 0, this whole node will kind of be deactivated. You could prefactor the pieces and create constraints for those new pieces, and then if a certain attribute on the packed points meets a threshold, remove those constraints. Yeah, I think you can do it with pin constraints, or positional constraints are the easiest. It just depends. I mean, that might be a bit easier because you could just like delete the constraints if you wanted to. But I'm already oh, okay, no worries. Oh, I didn't see that message before. Yeah, so I misinterpreted that. So I was saying you could kind of treat the frozen ones with just constraints and lock them into place that way. But yeah, I think that's the best approach, is to have constraints that are like able to be broken or just manually releasing them after a certain frame. I think it's generally just a bad idea to do like some people will actually do more fracturing and try to change the geometry during the simulation, but that kind of turns out to be a mess. And like using this transform pieces, like holding the static geometry and then updating it with your transform point cloud, that this whole approach goes out the window. Like your geometry no longer has a consistent topology and it just turns into a big mess. So the constraints and then releasing constraints after a certain time or threshold is definitely the way to go for that. So now we have our mask. If I want to visualize it, we could try it again. I don't know how easy it's going to be to see, but basically these, it's kind of hard because it's like an anti-gravity thing and they're already pretty chaotic, but basically this force, it stops injecting turbulence into things once the rebuild state is turned on. We can continue to verify it once we build this stuff in. So with this one, we just copy this text. We can mask this whole force scale with the rebuild. You could maybe put these attributes in this activation, but I'm not 100% sure if they evaluate like with local expressions or per point. So I usually do it down here. So that one is set up, and then we were also just increasing the force scale based off the distance from its where it needs to go, basically. We just want to do the same thing here. So mask the air resistance based off, don't apply any air resistance before the rebuild light switch gets flipped on. And I'm just gonna not deal with this one yet. This was a more advanced thing that we'll do later. And then these were additional rebuilding forces. So we want them masked out by that state. So with this torque and spin resistance, these are realigning to the rest, the input or unrotated direction. So they'll realign basically to the source. Looks like, I don't know if they're not strong enough. It might just be because they're like colliding with each other. They're starting to rub into each other. Yeah, because I was breaking glass, but pre-fractured glass looks not right in the render. Use the threshold attribute to enable the inside faces. Yeah, so if you're doing that based off of constraints, you can also check the constraint geometry to reveal faces if you need to. I'll try to find the file I was doing with this method as well. So I think we're good. We just clean up some of those old comments. I was just commenting out old stuff is kind of a bad habit. I don't know, like all this stuff here, you could delete it. I don't know if I'm going to use it, so I'll keep it around for a little bit, but like that color stuff, that attribute, I'm no longer using it for that reason, so it's just completely misleading to have that in there. Yeah, so I think we're pretty good. I could try this a bit higher. I don't know if, I have a feeling that they were just like mashing into each other too much, and that's what was causing the rotation to be a bit misaligned. So this is basically the reason I was like disabling collisions. If these guys get like one that should be on the outside gets in front of the other one, they don't have like logic or anything like that built into move like within each other, so they're always just kind of both of them are just doing this and like stuck. They're both kind of trying to get through each other, and they're both just locking heads. So that's the reason to disable collision. One thing you could do is like only activate or only rebuild the ones starting from the inside and then move to the outside ones. We could try that and just see how much it helps. We already kind of have that set up, I think. We just do the length. Like this way we should be able to turn on just the ones like in his brain area, and then eventually move outward from there positionally. So basically rebuild starting at the middle or the core, and then do the shell. So we just want to compare. Just going to go back to this visualization just to verify what we're doing. So we want to look at the rebuild state. Rebuilded. So it looks like we didn't even change it yet. So I was just doing this based off of a noise. We do the exploded. It might be a bit easier to see what's happening. Basically, like if one of these gets turned on and locked in place before these interior ones, then they might run into this one that's already like rebuilding before this one decides to rebuild. So that's why we get the current problems. So I'm just going to switch this to the length, just like distance from the center. So now we should get closer to building from the core. I might do some more offset of the point position. Just to make sure that I'm perfectly in the middle of his head. So something like that should be close enough to get started with. And then I think if I just change the scale or multiply this by a number, I think we want it to get smaller. Then we can make sure that everything gets included. So now when we go to switch on to our rebuilding state, it should happen kind of like that. This is my animation here for it, so I might just want to spread that out over a longer period of time. So these just have a bit more time to get where they need to be. It's also a bit bad to do this. So we can go in here and fix that. When you promote any of these settings just using the gear promote parameter, it will just get like its generic name. So for these compares, we were just promoting this input to, like compare to float, which this is named input to if you hover over it. So it doesn't get labeled at all. So if you just click on the nub or the little thing, there's actually a node here. Like if I do expose nodes, there's actually like a parameter node that's what this little line represents. But if you just click on it, that's kind of like selecting the node, the thing, and then when you just change the label, this one will do rebuild, and then this one will do released. So I don't want to change this name because that will actually change like variable naming and stuff like that under the hood. But just changing this label doesn't really affect anything else, except just makes it easier to understand up here what we're doing with this animation. So you could give this another try. See if our rebuilding is more successful. So we're getting a little bit better results. We have less stuff that's like fighting, trying to get together. I think this realignment torque and stuff is a bit too aggressive. Like they're too quickly rotating to the desired direction. So we'll try to fix that. The pop attract, we might want that to be a bit stronger. Maybe we just need less like resistance. So we're balancing the attraction and the drag to get stuff back together. We might want a bit less drag. Maybe this one. These numbers are just a bit too... It was like a kind of fall off field that I was doing here. So basically trying to add a lot more resistance once they get close enough. I don't know if this one I want. Maybe I want to multiply it like that so that it's... No, I think I was doing it properly. Let's see if it works. So even though this looks a bit messy, what I'm basically trying to do is just get the simulated performance looking as natural as possible. We are running stuff after to like sort out some small issues. We can do some more stuff here to really fix things. But basically like the simulation result, you want it to look as natural as possible before you move on to post simulation, like forcing things to really be in place. Otherwise, like earlier I was doing too much manually like overriding of parameters, so that's why it was starting to look a bit fake. Maybe this force is like a bit strong. Might turn it down a little bit just so it's like not as chaotic overall. So that's cool. And then what I'm gonna do down here is just add a timer. So we'll just do F at timer. This is a float. It will just be in seconds. If I just do plus equals rebuild, basically this way every time this rebuild state is active or the rebuild state is true or the light switch is turned on for rebuilding, this timer will start incrementing. It's a bit bad right now because like if you're doing sub steps, this could increase more rapidly. Like basically every time this simulation runs a sub step or a frame increment, it will add 1 to this value. So if I go outside of it, just look at the spreadsheet. I could see the timer there. You could see each frame, these are going up by 1 number. Basically, if we're rebuilding, this timer will increment by 1 every time the simulation runs. So if you want it to be a bit more precise, you can do F at time inc and multiply it by rebuild. So now I'm saying if we're rebuilding, add the simulation, the current time increment to this timer. So that's just a quick way to modify that timer or that value. We'll just let it cook a little bit. But now when it's incrementing, it should be the time in seconds. So even if we add more sub-steps or change other frames per second or stuff like that, this number will be more reliable or more predictable, which is usually good to do for simulations. Like this velocity is always units per meters, like units per second. It's just better with simulation to store stuff in seconds instead of like arbitrarily incrementing them by numbers. So this way, what I can do, I could say after my timer is greater than 1, I'm going to switch this around, do the timer is less than 1, and then I'm going to multiply my active state by that. So what this is doing is basically only treat these pieces as active when the timer is less than 1 second. So I'm doing multiplication to keep the current value up here as true. You could also like multiply these together in one line. It just depends how you want to work. But we can play it. You can see that that active is still masking that area. And then you can see here after they've been trying to rebuild or rebuilding for 1 second, they become inactive or stop. So the reason you might want to do that is that then we could go back to doing this lerping of the position. So basically what we're doing here is saying after 1 second of rebuilding, we're just manually going to start moving or interpolating the positions to where they need to be. So instead of doing the color nonsense, we'll just do fit, and we'll do this timer, 1 second to 2 seconds. If it's 1 second or less, just keep the current position. If it's 2 seconds, go fully all the way to its target position. Just mess something up. So I was making this into an attribute. Yeah, we need this to be an attribute because we need it to be stored on the geometry so that it keeps accumulating each frame. So now that still looks a bit natural. We have our rotation problems, but we've solved this to really lock them like rigidly into where they need to be. And then because we're doing this step at the end, this will properly seal the like deform the geometry into precisely the point position that it needs to be in. You could do something here with like the orientation. I think you'd need to do packed primitives and stuff to do that. We could just try going a bit higher with our scales here. Basically just trying to get it to align more quickly before we start moving things to where they need to be. So now it's looking a little bit straighter. Basically just want that alignment to be as good as we can get it before we resort to like this final hack or the final cheat to force everything to be where it needs to be. So now it's looking pretty realistic. Like it's hard to tell that I'm doing nonsense on top of it to force stuff in. Even these guys, you can see they're like trying to get in because I have that timer set for 1 second. Like with motion blur and stuff, you probably wouldn't notice that penetration, or it's better to have the penetration than to have like popping or stuff jiggling around and stuff like that. So it's pretty cool. We might also want to use this collision ignore again. I'm just gonna copy it from there, and we could do it here. So we could do like, we're basically saying if you're close enough to where you're trying to go, your distance from your current position to your target position is less than these units in meters. And then instead of this color, we can keep using the timer. So we can say the timer is greater than 0.5 seconds, half a second, and you're close enough to where you need to be, then turn off your collisions. What's cracking? How's it going, Alex? This man is what's cracking. So we're just trying to polish this up a little bit. Just getting some final tweaks in place, cleaning up naming of stuff. I was just making adjustments to these different, instead of using the color, I started making integer attributes that are like describing the current state, whether it's rebuilding or not, or whether it's released or not. And then this one I'll just do like update attributes from input geo. So we aren't using the color anymore. Like a switch, yeah. Like I was using that. I think that's a good way to think about it mentally. It's like a light switch or a button is like activate a lever. Oop. Release. It's like you're on a submarine. Release the missiles. Yeah, so basically we also made a timer here. So like when that light switch or when the switch of rebuild is set for longer than a certain time, then we're like manually forcing things back together. I think we might want to stretch that time period out. So we'll give it like 1.5 seconds before we start to override the position. Maybe this active, I'm only going to turn them into static objects or like manually updated ones after 2 seconds. And then this collision ignore will wait 1.5 seconds before we allow that condition to be set. So they were getting close. They were jiggling a little bit. I don't know if this one, I think we're getting stuff close enough that we can reduce this range a little bit more. So the smaller we make this range, the less force over, like manual overwriting of positions we're doing, the more natural it will work. So that's cool. We're getting pretty close. There's just a bit of jiggling and then it's the final position stuff. You do a lerp with position, but how do you make it orient itself correct? Yeah, it's just the pop look at. So this one, you just tell it target is direction and update it with this spin method. And then I'm basically saying the rebuild is active, then apply the torque and spin resistance. And basically these reference directions, just leaving them at default, is basically saying to use the input alignment, or like go back to its, revert to its original direction before the simulation, is basically the reason of leaving all that stuff blank. And then I'm just thinking right here, using the distance of position and rest is always going to be a bit forced, because it's never really going to let it get into its final position. A gem for sure. So what we're going to do instead of distance now, we have that timer attribute that we made. So we can use it down here as well. So we'll take the timer, and if it's 1.5 or less, then let me just finish typing this out. So we'll go from 1.5 to 2.5, and if it's 1.5 or less, just use the current position, and if it's 2.5 or more, use the starting position, or the frozen, the pre-fractured position. So basically, when the timer is before 1.5 seconds, use the simulation result, and then 2.5 seconds use the pre-simulated or final just destination. It didn't work. So this unpack, before we were moving the color because I was using it in here, but now we just need to move the timer. Boom, we did it. So now you can see after 1.5 seconds, they start easing into the position. It seems a little late. Maybe we want to do like 0.5 to 1.5 seconds. Now it's looking pretty natural. So this realignment, I'm gonna try going back down with it. I was also just pinning my view at that level to make sure that we're visualizing like that attribute, the post simulation deform like fixes, even when I'm inside of the simulation network. So now we can really play around and do, we're just much more sure of our forces and our results. If I wanted to, I could add this pop axis force back in. I just have to update these with the proper expressions are just much more readable. Basically, the orbit speed, only do it when it's released. Suction speed, only do it when it's released. And then I think we want this rebuild as well. Doing 1 minus rebuild is basically just saying when we're not rebuilding. So basically we only want to do these forces when we're either released or before we're rebuilding. And that's the only moment we want to do them. It's a bit, this is a bit like engineer, programmer speak or whatever, but maybe it's the best we can do. So now we're getting pretty nice results. I think we can even really rip some of this stuff around if we want to. It's a bit weird. just gonna go a bit lower, maybe a bit higher with this noise. So I kind of want a bit of wind or turbulence to break up that orbit so that it's not like a perfect cylinder that things are rotating around. But yeah, I think we did it. Naranjos, cool. Yeah, so I think we've made more progress. If I really wanted to keep doing things, maybe like keep fixing things up, maybe this green, we're saying green means go is like released. Red maybe means like stop. Is a bit too vibrant. Then maybe even just using these sticky notes. Rebuilding forces, and just do a copy of that. This one will do release forces. Wow, Kim. So now we have just a bit more clearly labeled stuff. And these are just kind of global, or these are always being applied. I'm just going to get rid of this one. We're not using it anymore. That was just some initial velocity. We don't need that. So we have stuff that's pretty straightforward now. This is like a much more, usually it's just a good idea to do this when you can. This way that your setups are just more modular, like compartmentalized or reusable. So if I quickly needed this effect, I kind of know that I need to use this to set these states. Look in here and see what those are affecting. And it's just a few sets of nodes, like 20 nodes or something like that, that I would grab. Gotta apply the high res now. They are not RBD, right? Means self-collision or physics. So they're RBD, and I'm using a timer. It's the strength of the forces based off the distance to the surface of the geo. For some of them I did that, like doing this drag to slow them, to deaccelerate them. This is basically saying only apply this drag when you're very close to where you're trying to go. Otherwise, let them like freely zoom back to where they need to be. But most of the forces are just being controlled using the switches. So when the state or the attribute is toggled on or off. They are not RBD, means self-collision or physics. So these are it's packed RBD. There is a bit of post simulation stuff that I'm doing that you would say is like not simulated or it's procedural or whatever, but basically they're getting pretty close to where they need to be before I'm manually like turning off collisions and overwriting the position and stuff. So I'm basically trying to do like 90% of the simulation using physics and using RBDs, and then just the final 10% or the final 2.2 units, or like just some final adjustments to really like put icing on the cake or whatever. So I'm basically trying to use the physics and the simulation to keep it looking natural, and then at the very end just start applying this stuff. So I don't know if I'm gonna have time to do the high res. I'm kind of trying to keep this around an hour or so. But you could always... Yeah, I know. Yeah, so it's just, you could do this fracture. You just want to keep the fracture points the same. And then you could even do it before the remesh, I think. You just need to make sure maybe that these, sometimes you get a bit more pieces on the high res. We'll see if we can see how quickly we can get it. I'm just gonna switch it. Oof. This guy, he doesn't like to be stopped. The Voronoi split, it will just go like canceling, ... canceling, ... I think just using the remesh would have been better. But yeah, I think just fracturing them using the same set of fracture points, you'll get a pretty similar end result. Sometimes the piece numbers are different after you pack them. Usually what I do to fix that is just using an attribute transfer. So like spatially, it'll just get the nearest position or the nearest piece name of the proxy or simulation, and then just applying it down at the bottom there. Why this model? I didn't catch the first part. I just was quickly grabbing something from my folder. It just looked like an interesting head bust or whatever. I think it's like something people use for drawing or sketching, because it's like it has the different panels. It looks ugly. It looks a bit ugly with them fractured, but thought it was interesting because it's like a synthesis of organic and kind of hard surface. Like it could be like a Terminator robot or some kind of cyborg or something like that. But there wasn't really much thought put into it. It's just something that just a test model or whatever. So you could replace this with whatever you want, but there wasn't really a bigger meaning behind it or anything like that. Yes, I don't know if I think I borked it with this. I should have just done it with the remeshed one, because I think this model is pretty high res. No worries. It's not a big deal. It would have been nice. I think I could have, if I'd done the remesh, I could have gotten it hooked up in like under a minute. But it's just this Voronoi split. I feel like this, I don't know why they can't, it's like one of the only nodes that you, even after you press escape, it doesn't want to stop. Sometimes what I do is like, just go in here, and then if you do this process list, so like it would be this Houdini, then you could do kill the process ID. I think this has to be in all caps maybe. Ooh, it did it. All right, I think we're good. So the basically it knew I was about to kill it, and so it fixed itself. Let me just get this out of the shell. So basically this remesh, it will still look very clean, but it's making a lot less points, which should speed up the Voronoi split. You found some nice artworks here, or this is something you made, Umair? Ooh, it's pretty cool. It's like LiDAR scanning or something. Yeah, usually my setups, like I'll start out very sloppy and just be exploring or whatever, but once you find something that works and is pretty reliable, it's nice to kind of document it or go back and just do a run, clean things up. I usually find that like at the start of the day before you start working, or after you come back from a break, it's a good time to just go through and like quickly clean stuff up or remove stuff. you wait all the way till the very end, it might be like too intimidating and you just never want to clean stuff up, like it will just get too out of hand. But usually, I don't know, if I'm especially doing these streams and stuff, I'll try to keep it pretty clean. Yeah, this is pretty cool. The stuff at the start, I think, is my favorite. This kind of like scanning effects. It's pretty cool. Kind of reminds me of that stuff that Matt Ebb was doing or whatever. I don't know if this will search it, but he had this like terrain that he was flying into, and like it was all made of like waveforms, kind of. I think this is it. Clicked the wrong thing. We'll go back to it in a second. So we'll just try to do this quickly. I think I forgot to add the normals before. So I'll just add normals to everything. It's a bit sloppy, but for now, just working quickly, it's okay. Then I just want to do this assemble. So we have 1,122 pieces. Here we have a different amount of pieces. That also means that the numbers and stuff are probably different. You can try to connect it here. Just gonna get rid of that other stuff. So this is basically trying to take the low resolution transform pieces and apply it back to the high res. Then we would just need the counter and some of the other stuff. So I think, let me just, so we want to make sure we have rest before we pack. You can also do rest down here, it's still like in the rest position. And then I think might be able to just do, let me see, maybe attribute copy. Maybe up here, we want to get the timer and we want to match by the name attribute. So we have the name on primitives here, and then here the name is on the points. So I think we just want to promote that, and then he should be able to find it. So we'll just switch this to primitive, promote the name, and then the warning went away. Now he's getting the timer. Then I think we can just plop that one in right there. We did it! Woo! Foggies! Yeah, so this is pretty cool. So just get rid of some of this other stuff. Just get rid of it. Yeah! Yeah, so this is just the applying the simulation low resolution and then doing high resolution geometry and applying the same simulation transforms and stuff like that to it. So it's pretty clean. Just doing simple steps, fracture, controlling, setting up our state attributes, simulating, rebuilding. Boom, boom, boom. Yeah. So probably gonna leave it here. Get out my Twitch Red Bull soda can. Yeah, and I'm probably gonna end it here. And then this is going to be the last for right now, or for some time, that we'll work on this rebuilding effect. So we did like 3 sessions of it. Just do a new folder. So if anyone has any questions just about this stuff, now's your chance. 15th. This should just be version 5. No questions? All right. Yeah, of course. If anyone has any Twitch, Amazon Prime that you're not using with Twitch, you can link it and subscribe to me, and it will help everyone. Will help the algorithm, will boost the channel, and it hopefully help the community grow. If you're not subscribed, it's nice to support this kind of stuff if you can. I understand if you're in a financial situation or anything like that. I don't want to force people into doing it. But if you have the free Amazon Prime, link it up. I think you're already subscribed with a gift sub, but basically if you just like look at the Twitch window, there should be a heart button maybe for subscribe. And then in that dialog, you'll see somewhere a button to link to your Amazon account. And then if you're already using Amazon Prime without paying anything additional, you can link it up and be subscribed to me with your Prime. I think you'll get a little crown like this. This means that these people are primers. And then that just helps out the channel. It helps me out. So it's nice if you do have an unused Amazon Prime on Twitch, then you can link it up with my channel and help me out. All right, so we'll call it here. Yeah, thanks anyone who subscribes. I greatly appreciate it. With my tutorials, I'm going to add all the subscribers to the end of it, like the credits page or whatever. So when I post that Sandman tutorial, anyone who's subscribed on here will get a little shout out, which is nice as well. Yeah, so we'll be back Friday doing the cool zone, doing the weekend thing. Hopefully see everyone there. Take it easy.